Okay guys, after this video you're gonna see wiring schematic. My preference is Mitchell 1, and what I want to explain here is the heater auto sensor circuit problem. And you don't need big expensive tool to troubleshoot this problem. It's a simple test you can do by disconnecting a sensor. This is the connector here. You disconnect the sensor, and what you do, take a regular meter, in this case I'm gonna take this out. I don't gonna punch the terminals, very important not to do that. And I want the meter to make a noise when it's continuity. As you can see there, it's making a noise. Now what I want to show you here, and this happens a lot, the people doesn't know what cables to touch. And I don't know if I can focus there, but these two wires, white wires, they're the heater. One is computer control, a signal high and low, and the opposite side. And one of these wires will supply 12 volts, and another one will be either computer control or however the designer of the engineer do with the sensor. So that is very important when you gotta go and decide, or you get a universal connector. That I never recommend that. I always recommend the original connector sensor like this. So by touching the two wires here, if I don't got in the two wires, the two white wires, if I don't got no continuity there, I'm gonna touch this. Again, I'm not pushing it in. Let me see if I can let you see. I'm not pushing it in, I'm just touching. And you hear my meter making the noise. What you're testing there is the continuity, and if I touch the two back wires, you see, I don't got nothing there. But if I touch the two white wires, I do have continuity. So that is my heater that is inside here. There is something like that inside the sensor. Okay? So that is that with two white wires. I bring another sensor. And you see the color wire here. The color wire here, you got one white, one blue, and two black wires. So which one is my heater here? Is my two black wires. Okay? So what you do with that, same test. My two black wires, I touching that one. And you can hear, I don't know if you can see it there. And this one probably I can use, no, this one is too. This one is too, let me see. Maybe, oops, nope. Okay, let's see. If I can do it better like that so you guys can see it. And that's the camera. And that is the two black wires. So if you're testing disconnecting a sensor and you don't got continuity there, that's a sensor that has got to be replaced. And then you can see the way you connect this thing. You can see, and with a meter test if you got the 12 volts coming in, fit wire for it. Different designs. Some cars got a fuse, another one got a relay. Chrysler used the auto shutdown relay. Also, I seen fuses too. GM uses fuses. Subaru, they got the main relay related with that. So when you jump, but the easy test is the one that I show you now. If that don't pass the test, is the sensor, change it and your problem will go away. Okay, so let me explain this to you here. Now that I got you here, this pink and black wire and the schematic that I'm gonna show you is coming up is supplied 12 volts to the heater, bank 2, sensor 2, and bank 1, sensor 2. This guy, pink and black wire, it will supply the 12 volts to those sensors, okay? And then the pink wire, it will supply the 12 volts to the heater, bank 1, sensor 1, and bank 2, sensor 1. As you can see here, I put 2 white wires in that guy. That don't mean nothing. I just let you know either the 2 white wire is a heater control, either the 2 black wire is the heater control. Okay? Now, one supplies, the pink wire supplies, the other one is controlled by the computer. So the computer is a push to ground. Okay, this will supply ground to this sensor so they activate the heater. Okay, so let's say you got a problem that this got 12 volts and this guy don't have no ground here when you got the switching on or the car running. So you got to check the wiring schematic and go from there, and you probably got a pin backed, put a pin behind the computer, and if you got the ground supply from the computer, that means the wire is open somewhere, the harness. Okay, so that is one of the situation. Now if you can see in the design that I put on the bottom here is a different design, and you can see this guy always here with little holes, and a hole in the center usually is close to the manifold. That don't mean nothing also, but it's if you work in an original car and you pull a sensor like that and put a sensor like this will get more heat and it will create a cat efficiency problem. So you got to make sure whatever you're taking out of the car, and it's his original car and the sensor looks like this, you want to put the same sensor design for that car. Okay, because I seen problems that they put sensor like this and sensor like this and they got cat efficiency because this, by having more holes, get more heat, so it works faster than the other one and it creates problem. Now to name a few, just name a few, P0141 auto sensor heater circuit bank 1 sensor 2. That means the downstream sensor. I put in a 4-cylinder car is a downstream sensor. Okay, so if you got the engine and the manifold, usually in the 4-cylinder you got this sensor right in the top and the manifold there. So that is your bank 1 and that 4-cylinder. The bank 2 is the one is under the car. So that is the one. It's got to be troubleshoot for the heater problem. In this case, in a P1133 heater O2 sensor, bank 1, sensor 1, I put a note here. In this case, bank 1 on this, on the driver's side, is on the driver's side, the sensor near the exhaust manifold, and a 4.3 liter GM product. So that's very important when you work in 8 cylinders and V6 cylinders to identify where's your bank 1. And the thing that I do with identifying that, I go to a fighting order. You can Google that and put fighting order, and he will tell you where the number 1 cylinder is. By knowing the number 1 cylinder, you know the number 1 cylinder is related with the bank 1. So number 1 cylinder, if it's a 6 cylinder and you got the number 1 and the firewall between the engine and the firewall on a 6 cylinder, that means that's your bank 1. The opposite side that is near the radiator, that will be your bank 2. So this is the easy way. You don't need fancy tools. You disconnect the sensor. If you don't got continuity and these 2 wires and the white wires or the black wires, that means the sensor, this is open. This heater is open here, and it's not, you don't make contact with another part of the heater, and that will not hit the sensor, and that will create the computer to see an open circuit and to trigger that heater sensor problem. Now that is something that you guys gotta disconnect it and test it, and it's simple. You need just a regular meter that give you continuity, and that will take care of that problem. Now when the video is coming up is when you got problems and with schematics and how to identify problems and pull up or push down design, and that's how you can determine this. You don't want to start jumping wires and doing stuff like that, because you can damage your computer. So when you got problems that is not in the sensor here, and you're not having a good wire schematic, do not supply power or do not put any power to the computer that you can burn something. So that I recommend a trained technician to do that, and with a wires schematic. My preference Mitchell 1, because I've been dealing with Mitchell 1 for many years, and Snap-on used the chop key, which is the same Mitchell on demand. So good luck with that, guys, and thank you for watching. Okay guys, I'm sorry about that in the video before this. So I plug in this in so you can see the better picture. This is my 2 white wires. If you look the connector, it will be these 2 guys here. The another one is the high and low signal for the sensor in the computer. So if I take this guy out of here, that's when you're doing yourself video, that's what happened. So bear with me here. So I should show continuity and my 2 white wires. I'm not pushing it in, I just touching, and you see that is continuity from the heater and the sensor, so that means this sensor is good, and the heater part of it. Okay, so there's many things that can go wrong, but in the heater part is good. I'm gonna show you the another sensor that is with two white wires. Now this sensor here is with two black wires. I should use this sensor first because now I gotta put back the adapters to the cables from the meter. This is something quick. Now we got here the two sensor, the O2 sensor, in this case the two black wires. See these two black wires, they're gonna be the heater, okay? And the white and blue wire is gonna be the high and low from the sensor. So you wanna have continuity in the two black wires. Okay, and the two black wires, if you look at the sensor here, is in the flat side of the connector here, so it will be my two bottom terminals in that one. So what I'm gonna do with this one, I gonna connect one, and then another one I'm gonna take it away so I don't touch another contact. And I just gonna touch the other one. You hear the beeping in the meter? That means it's continuity in the heater. That means the heater also and this sensor is good. So guys, I'm sorry that in the video I don't show that. It was off the screen, so that's why I plug in this. Thank you guys. Okay guys, today we're gonna talk about O2 sensor heater circuit problems. In the back here you're gonna see the schematic I'm using, Mitchell 1. A little info about this: you cannot buy this program. This program is a licensed program that you gotta buy the program and you gotta pay a monthly fee. Okay, and this program, my friend gave me access because he got a garage, so I can make this video. Now, Mitchell 1, you can go to mitchell1.com and you can buy this program. I think they let you buy to work in one car for $16 for 1 month, something like that. So you can do that in their website. And the car we're gonna work today is it's a Chevy Silverado. Here, 2007 with the VIN number 0, and we're gonna work in the heater O2 sensors. Now, it's a simple thing and it's a very complicated thing. The reason why is because when you go and disconnect the sensor and you don't got continuity in the heaters, then you gotta go to the schematic and see what is going on. And the best way to do it, my preference is Mitchell 1 because I am very familiar with it, and I've been working with this for many years, and that's why I love it. Snap-on column shop key is the same program. I believe either Snap-on bought Mitchell or Mitchell bought Snap-on. So I don't know the story behind it, but that is the reason. Snap-on used this program. Now we troubleshooting heater sensors, and when you troubleshooting heater sensors, you gotta go to the heater here, and this let me get it. You can see it here, say HO2, heater O2 sensor. HT means heater. This is bank 2 sensor 2. Okay? But this here is the control for that heater. This is not the power supply for the heater. So right there you're gonna know if I got power and another wire, this will supply ground. Okay? When it controls the heater, it will supply ground. So if I go to page 2, and this pink and black wire, they're my heater positive for the bank 2 sensor 2, bank 1 sensor 2. So if I give you here, sorry about that. And then this guy here, I want to get you green on the screen here. My pink and black wire, let me take this out here so you can read it. Pink and black wire, their O2 sensor B stands for A is bank 1 and B is bank 2, and sensor and the fuse is number 9 and it's a 10 amp. Where this fuse is? Under the fuse block left side of the engine compartment. Okay, so now we got this guy. So how I know that my wires for the heater and the computer, they're ground, they're controlled by ground, because these guys, they're positive. These guys supply the 12 volts. Okay, so that means my computer control this sensor by ground. Now over here is a note, and it's got a letter A to O2 sensor A, which is bank 1 sensor fuse number 19, and diagram 3 of 4. So we're going, this is diagram 2 of 4, so we go in 3 of 4. And this is our pink and black here. Sorry about that, that is not it. And the pink and black is for the bank 2. Pink, no trace, no black trace, it's only pink. It goes to these guys here. Let me get this bigger here. Okay, so over here, O2 sensor A, which is bank 1 sensors, and the fuse is the number 19, and also a 10 amp fuse. And where this fuse is? Under hood fuse block, left side of the engine compartment. Now, when you need schematic like this, is because the simple tests don't pass. Pass. I'm sorry about that. The simple test of the heater sensor is when you take the sensor, the two heaters, and you connect a meter. A meter like this. Turn it on. See here if I can get my okay, you got in the two wires that goes for the heater and the sensor, and you touch one end and the other end, and if you don't hear the meter beeping, the heater inside the sensor is open. That is automatically change the sensor. You don't want to repair those wires. Those wires, they're hard to repair. So if the wire is cracked from the connector to the sensor, it's better to replace that sensor. For any reason that you gotta use a schematic is if somebody cut the original harness in the car, if you buy a universal sensor that you gotta know what wire to connect, and I recommend that professional technician with a proper wiring color do that, and a good schematic like this. So let me go back to the first schematic here and show you. That my pink and black wire, those guys there, pink and black wire, this is our heater inside the sensor, and this is our control, the gray and white. The orange and white is our control from the computer, and this is our heater. Okay, so be careful when you're doing that. And when they got wires like you don't know how to identify, so you need a good schematic like this. Like I say, you can get this Mitchell one for 1 month, I think is $16, and you can go and check your TSB, check everything about that car that you're working on. And thank you guys for watching.